Welcome to the Transum Podcast, a monthly roundup of the new features on the transum.org website, providing mathematical puzzles, games, learning activities, and the ever-popular mathematics lesson starter of the day. Here's your host, John Tranter.
Welcome to Transum Podcast number 119 for October 2024. So if the coming month brings along this year's occurrence of Halloween, based on a 2,000-year-old Celtic festival, then last month, in contrast, brought me something brand new. Yes, the highly anticipated OpenAI Advanced Voices came to my iPhone. Good morning, ChatGPT. How are you this morning?
I'm doing well, thank you. How about you? How's your morning been so far?
Yeah, all is going well so far, thanks for asking. Okay, could you tell me the puzzle of the month for October 2024?
Vesper bought a number of pumpkins in one shop at the rate of 4 for £20. He then buys the same number of pumpkins in another shop at a rate of 6 for £20. What was the mean number of pumpkins that could be bought for £20?
That's the Transum puzzle for this month. The challenge is set, have a think, make a plan. You have 1 month to figure it out. Send in your solution as soon as you can.
Please let me know if you solve the puzzle. An email to podcast@transum.org would do very nicely, and I would love to hear from you. The solution and the credit for the puzzle will be in next month's podcast. Okay, so while you think about that, here are some of the key resources added to the Transum website during the last month. Diophantine Equations is a new set of exercises providing students with a quest to find whole numbers that make the equations true. Now, the equations have more than one unknown, so traditional equation solving techniques won't work. But if you haven't encountered Diophantine equations before, have a go at the exercise yourself. The link is in the newsletter, transum.org/newsletter. As is the link to all the other things that I'll talk about in this podcast. Framed Numbers is a new starter, but it's also included on the Maths Puzzles page. I've adapted this challenge from what I've seen in a number of places, but as yet I haven't found the original source of the idea. It surprisingly lends itself to a trial and improvement strategy, though it's quite different from other maths puzzles. Platonic Solids is a new activity, but will hopefully help pupils understand basic geometric concepts such as faces, edges and vertices. Level 2 brings in the nets of the solids, so that's just yet another resource in the range of nets exercises that are on the website. It really makes my day when I receive information about someone who has spent quality time using a Transum resource. This particular instance gave me a jaw-dropping moment, a video of Gracie Swartz completing level 1 of Divides Exactly in just 6 seconds. And the video proves that she did it in 6 seconds. Amazing. I love the cries of, got it, I got it, I got it at the end. Now there's a challenge for your students. On the 3rd of October, there's an excuse to be poetic. It's World Poetry Day, and yes, you guessed it, I have created a page of mathematical poems for you to enjoy. I have predictably called the resource Maths Poems. See what I did there? And the page contains links to topic-specific poems I've written and collected over the years. The month of October ends with
Halloween.
The starter of the day for the 31st has spooky music and screams. making the day memorable while solving ghostly maths problems. And there's also Trick or Treat, Squarder, and Double Double Halve and Treble. All activities themed around Halloween. There's only one thing I don't like about Halloween, which is...
You can find Transum Mathematics at www.transum.org.
My friend Alan, who teaches at an international school in Germany using a German language textbook, sometimes shares interesting snippets from their curriculum. One such topic not typically covered in the British curriculum is Heron's method, der Heron-Algorithmus, or something like that. This ancient algorithm, devised by Heron of Alexandria in 1st century Egypt, was the earliest known way to compute square roots. The method involves making an initial guess and repeatedly refining it by averaging the guess with the quotient of the number divided by that guess. Though not widely taught today, Heron's method remains a brilliant example of early algorithmic thinking, and you can have a go at it using the square roots exercise. Don't forget, all the links to these activities are in the newsletter, transum.org/newsletter. A new area on the Transum website has been set up to celebrate the history of mathematics. I do not need to tell you any more about this resource, thanks to my next discovery. So, are you sitting comfortably? As you know, I have been fascinated by the recent avalanche of new artificial intelligence facilities. My latest discovery is Notebook LM. The audio overview feature in Google's Notebook LM is designed to transform uploaded documents into engaging audio discussions. This feature aims to help users understand complex information by generating a conversational summary presented by two AI hosts. So I gave it the new History of Maths resource. I basically just pasted the URL of the History of Maths page into Notebook LM, and it came up with a 13-minute discussion. You can hear about it in a moment, but let me just tell you that I have been super impressed by this. Listen for yourself. The AI hosts, these sort of artificial voices, you really can't tell they're artificial. They're the most realistic I've ever heard. As the young people say, I was really blown away by this. So, here we go. I will hand over to the two nameless hosts.
Okay, so today we're diving into the history of mathematics.
Right?
And I gotta admit, when I first saw this stack of excerpts from the history of mathematics on the Transum website,
Yeah.
I kind of thought, oh boy, this is gonna be a long one. But let me tell you, this isn't your dusty old textbook stuff.
Oh, you're right to be wary.
Yeah.
Math history often gets presented in a very dry, factual way.
It does.
But there's so much more to it than just dates and theorems.
Exactly.
Yeah.
And this Transum source does a great job of bringing that out.
It does.
For example, they have this whole thing about imagining a classroom timeline that goes all the way back to 600 BCE.
I love that idea.
Really?
Yeah.
You know, like those timelines we used to have in school?
It makes history feel less abstract.
It does, right? Anyway, this got me thinking about how much math was going on even back then. I mean, they didn't have calculators or computers or even those fancy slide rules.
And this is where it gets really interesting, because around 600 BCE, we see this crucial shift in how people thought about math.
Okay.
Before that, it was primarily about practical matters, like accounting and measurement.
Basically just keeping track of things.
Exactly.
Okay.
But around this time, mathematics started to transition into a more abstract intellectual pursuit. Think of it like this. Instead of just asking how many, people began to explore the deeper relationships between numbers and shapes, seeking out patterns and underlying principles.
So it went from being a tool to being a subject in its own right.
Precisely.
Wow.
And that shift was monumental. It paved the way for incredible advancements in geometry number theory and ultimately the development of mathematics as a distinct field of study.
That's amazing. I never realized how significant that shift was.
Right.
And you know, this transom source also mentions an activity called mathematician pairs that I thought was kind of cool.
Oh, I like that activity.
Yeah.
It's a fun way to learn about the key figures throughout history and their contributions.
Right. It's like a matching game, but instead of matching socks, you're matching mathematicians with their big breakthroughs.
And speaking of mathematicians, it's important to acknowledge that for centuries, the field was dominated by men.
Right.
But we shouldn't overlook the contributions of women like Hypatia of Alexandria.
Hypatia of Alexandria. I've never heard of her.
She was an incredible thinker who lived in the 4th century CE. Not only was she a brilliant mathematician, but she was also a renowned astronomer and philosopher.
Wow.
Her work on conic sections and algebra was particularly groundbreaking.
Wow, she sounds like a total rock star. I can't believe I didn't know about her before.
Yeah.
It's like there are these hidden figures throughout history just waiting to be rediscovered.
Exactly.
Yep.
And learning about people like Hypatia challenges our assumptions and enriches our understanding of how math has developed over time.
Okay, so from classroom timelines to ancient mathematicians, this deep dive is already full of surprises.
It is.
And wait until you hear about the oldest proverb they dug up from some ancient papyrus scrolls. It's wild.
Oh, I do love a good historical anecdote.
I bet you do.
Tell me more.
Okay, so picture this. Ancient Egypt, around 1650 BCE, someone's carefully writing on this papyrus scroll and they jot down this little gem. Accurate reckoning, the entrance into the knowledge of all existing things and all obscure secrets.
Wow. It sounds like they already understood the power of math back then.
Right. They saw it as the key to unlocking the mysteries of the universe.
Yeah.
Which actually makes a lot of sense when you think about it.
It does.
Math is all about finding patterns and relationships, about bringing order to chaos.
It's fascinating how that idea still resonates today, even with all our advanced technology.
Yeah.
There's still this sense that mathematics holds a certain power,
Yeah.
a key to understanding the world at its most fundamental level.
Absolutely. Although I'm personally quite grateful we've moved on from those old school calculators they show pictures of in this source. You know, the ones that took up half a desk?
Right.
I can barely operate my smartphone calculator sometimes.
I have to admit, I do have a soft spot for those vintage machines.
Really?
But you're right, our modern devices certainly make calculations a bit more manageable.
Just a bit. Speaking of which, let's talk about the Pythagorean theorem.
Okay.
I mean, who hasn't heard of a squared plus b squared equals c squared?
It's one of those mathematical concepts that has truly stood the test of time.
Totally. But get this. This transom source points out that the Babylonians actually knew about the relationship between the sides of a right triangle over 1,000 years before Pythagoras.
That's right.
What?
There's evidence from a clay tablet called Plimpton 322 dating back to 1800 BCE that shows they were already working with these concepts.
That's incredible. So it's not like Pythagoras just magically came up with this theorem out of thin air.
Exactly.
Yeah.
It highlights how mathematical knowledge can develop independently in different cultures and time periods.
Right.
It challenges our assumptions about the linearity of discovery.
And it makes you wonder how many other mathematical marvels might be hidden within the annals of history just waiting to be rediscovered, right?
Precisely. It's a reminder that the history of mathematics is full of twists, turns, and unexpected connections. Speaking of connections.
Let's talk about a journey. And no, I'm not talking about a weekend getaway.
Right.
I'm talking about the fascinating journey of our good friend, the decimal system.
Right.
Get this. It originated in India. And we're back.
We are.
Delving deeper into this fascinating world of math history.
Yes.
Before the break, we were about to embark on a journey. Not a literal one,
Right.
though I wouldn't mind a trip to ancient India right about now.
Ah, yes. The journey of the decimal system.
Yeah.
It's a story that really highlights how interconnected our world is.
It is.
Yeah.
Right. So it started in India, then it made its way over to the Islamic world, and eventually it landed in Europe sometime during the Middle Ages.
And that arrival in Europe was a game changer. You see, before the decimal system, European mathematicians were using Roman numerals.
Oh, yeah.
which, as you can imagine, made even basic calculations incredibly cumbersome.
Oh, I can only imagine. Trying to do long division with Roman numerals sounds like a special kind of torture.
Exactly.
Yeah.
So the adoption of the decimal system, with its elegant system of place value and those lovely zeros, revolutionized European mathematics. It made calculations significantly easier, freeing up mathematicians to tackle more complex problems and paving the way for advancements in fields like algebra, calculus, and astronomy.
It's amazing how something we take for granted now,
It is.
like the way we write numbers,
Yeah.
had such a profound impact on the development of math. It really makes you appreciate those unsung heroes of history, the ones who brought these ideas to new places and helped spread knowledge across cultures.
Absolutely. And speaking of spreading knowledge, it's fascinating to consider how mathematical concepts themselves have traveled and evolved over time.
Okay.
We touched on algebra earlier, and I think it's a great example of this cross-cultural exchange.
Right. We were talking about how the word algebra itself comes from the Arabic aljo.
Precisely.
Mhm.
And it comes from a 9th century book by the Persian mathematician Al-Khwarizmi. His work was instrumental in introducing algebraic concepts to the Islamic world, and eventually these ideas made their way to Europe, where they had a profound influence on the development of mathematics.
So we have these ancient Indian mathematicians developing the decimal system.
Mm-hmm.
Then centuries later, Persian scholars are building on that foundation to make incredible breakthroughs in algebra.
Right.
It really shows how much we owe to this global exchange of ideas.
It does. And it challenges us to reconsider the traditional narratives we often hear about the history of mathematics.
Okay.
It's not just a straight line from point A to point B.
Yeah.
It's a rich tapestry woven from the contributions of diverse cultures across centuries.
And that tapestry is still being woven today, right? I mean, we're constantly making new discoveries, pushing the boundaries of what we thought was possible.
Exactly. And the more we learn about the history of mathematics, the more we realize how much we don't know.
Right?
It's a humbling thought, but it's also incredibly exciting.
It is. It makes you wonder what incredible breakthroughs are just around the corner. But before we get too carried away with the future of math, let's bring it back to the present for a moment.
A wise idea. It's easy to get lost in the grand sweep of history.
It is. But one of the things I appreciate about this transom source is that it doesn't just present these historical facts in isolation.
Right.
It also encourages us to connect those dots back to our own understanding of math today.
And that connection is crucial.
Yeah.
After all, what's the point of learning about history if we don't allow it to shape our present and future perspectives?
Right. So I'm curious, from your perspective, how does this awareness of diverse contributions from ancient Babylonians to Indian mathematicians and Persian scholars, how does that change how we see math today?
That's a wonderful question, and I think it gets at the heart of why this deep dive into math history is so valuable.
And we're back for the final part of our deep dive into the history of mathematics.
We are.
I have to say, this has really changed how I think about math.
It has.
It's not just about formulas and equations. It's a story of human ingenuity and collaboration across cultures.
I completely agree.
And like any good story, it makes you think about the characters, the plot twists, and where it all might be headed next.
Right.
Speaking of where it's all headed, I'm curious to hear your thoughts on something.
Right. We've been talking about how the decimal system journeyed from India to Europe and how algebra has roots in 9th century Persia. So for someone hearing all this for the first time, how did these diverse contributions change how we see math today?
It's a great question.
Yeah.
First off, I think it helps us break free from this idea that math is a purely Western invention.
Right.
For a long time, the narrative focused heavily on contributions from ancient Greece and Europe.
Yeah.
And while those contributions are undoubtedly significant, they only tell part of the story.
It's like we've been missing out on half the cast in this grand mathematical play, right?
Exactly.
Yeah.
And when we start to acknowledge those missing voices, when we recognize the brilliance of mathematicians from India, China, the Islamic world, and indigenous cultures around the globe, it changes our whole perspective. So it's not just about being politically correct or anything like that. It actually enriches our understanding of math itself.
Absolutely.
Yeah.
It shows us that there are multiple ways of approaching mathematical concepts, different lenses, through which we can view problems and find solutions.
Okay.
For example, the way ancient Indian mathematicians developed the concept of zero was revolutionary.
It was.
It wasn't just an empty space. It was a placeholder, a concept that opened up a whole new way of thinking about numbers and infinity.
It's like those optical illusions where you can see two different images depending on how you look at it.
Right.
This whole deep dive has been like that, shifting perspectives and seeing math with fresh eyes.
That's a great analogy.
Yeah.
And just like with those optical illusions, once you see it, you can't unsee it.
You can't.
Recognizing the global history of math changes how we approach the subject itself.
Okay.
It encourages us to be more open-minded, more curious, and more appreciative of the diverse ways of thinking that have shaped this field for millennia.
This has been such an eye-opening conversation.
It has been.
And for our listeners who want to keep exploring, this Transom source is fantastic.
It really is.
They actually include QR codes for each mathematician so you can delve deeper into their lives and work.
That's a great resource.
It's like having a personal guide to the history of math right at your fingertips.
And that's what's so exciting about math history. It's an ongoing journey of discovery.
It is.
As we continue to uncover lost texts, translate ancient manuscripts, and reinterpret historical evidence, we gain a deeper appreciation for the interconnectedness of human knowledge. It's like we're all part of this giant collaborative effort that spans centuries and continents.
That's pretty inspiring when you think about it.
It is.
Yeah.
And who knows what incredible discoveries are still waiting to be made, what connections are waiting to be forged.
Wow.
The history of mathematics is still being written, and each new generation has the opportunity to add its own unique chapter to this incredible story.
I love that.
Me too.
So as we wrap up this deep dive, I think the biggest takeaway for me is that math is anything but boring.
No, it's not.
It's a living, breathing field shaped by human curiosity, creativity, and collaboration.
Couldn't have said better myself.
So until next time, keep those minds curious and remember that behind every equation, every theorem, and every mathematical breakthrough lies a fascinating story waiting to be explored.
So I hope you agree with me. That is really phenomenal, and it required hardly any work from me. All I did is pasted the URL of my webpage into the system, and it did the rest. Absolutely fantastic. So finally, the answer to last month's puzzle, which was...
In preparation for the cold weather, a large group of people dressed warmly in different ways. 1/4 of the people who wore hats also wore scarves and gloves. 1/5 of the people who wore scarves also wore hats and gloves. 1/6 of the people who wore gloves also wore hats and scarves. There were twice as many people wearing exactly 2 items as were wearing exactly 3 of the mentioned items of clothing. What fraction of the group wore all 3 items? Hats, scarves, and gloves?
The answer is, drumroll, 1/11. The first 5 puzzle solutions were received from Kevin, Marla, Rick, Leonard, and Shrek. Thanks to everyone, though, who sent in their thoughts. I really do appreciate reading your emails. And you can see some of the working on how that solution of 1/11 was arrived at the bottom of the newsletter page. That's transom.org/newsletter. And it's the newsletter, obviously, for October 2024. Okay, that's all for now. Apart from to say, I couldn't decide whether to teach my students the sign rule this Halloween or just hand out some Cadbury mini chocolates. So I asked them, trig or treat? Bye.
Thank you for downloading and listening to the Transom podcast. You can find the website at www.transom.org, where you're welcome to use all of the activities absolutely free, or jump in with both feet and become a Transom subscriber.